In lesson 2.3, we're going to start seeing multi-step equations that we need to solve using the multiplication principle and the addition principle, but we're also going to start using some of our distributive property, and there's going to be some simplifying that we can do. There's also going to be some clearing fractions, and there's going to be some interesting things that happen with solutions as far as maybe not getting a solution or infinitely many solutions. So the key terms: we remove parentheses in an equation by multiplying using the distributive laws. We multiply every term on both sides of an equation by the least common multiple of all denominators in order to clear fractions, and we will see an example of that. When solving an equation, if we end with a true equation, the equation has infinitely many solutions. And when solving an equation, if we end with a false equation, the equation has no solution. So let's start off by just looking at a couple two-step equations. So the first one, 3x plus 5 equals 29. The first thing I'm going to want to do is try to isolate the x term. I can't quite isolate the x all by itself yet because it's attached to a 3, but I'm at least going to isolate that term. So I need to move my 5, and since it's a plus 5, I'm going to put in a negative 5. That's going to get those to zero out, and that's going to leave me with 24. And now I can divide everything by 3, and that's going to give me x all by itself. So it looks like x is 8. And again, I could check my answer to make sure that that is correct by plugging it back into the original. So if I do that, 3 times 8 plus 5, does that equal 29? 3 times 8 is 24, plus 5 is 29. So yes, it does check out. So now here's some equations that we might have to do some simplifying first. All 4 of these equations are very similar in that they can be simplified on the left side because I have some like terms. So if I look at, let's say, number 12, 6x and 5x, those can both be combined because they're both like terms into 11x. So you always want to simplify if you can before you start solving. And now, when I divide both sides by 11, since it's a multiplication problem, I'm going to get x equals 132 divided by 11 is 12. And again, you can check that by plugging that back in for x if you wanted to. If we look at 13, again, these are like terms on the left side, so negative 3y, negative 4y will combine to negative 7y. And again, this is just a simplification before we actually start solving. Now that I'm here, I can divide both sides by negative 7. And that's going to leave me with y equals negative 4. Now these are getting into simplifying. We might have some like terms, but you're also going to start seeing variables on both sides. So we're going to have to address that issue. So let's start off with 16. If I look at the left side, 8x plus 7, I can't combine those. And if I look at the right side, 3x plus 12, I cannot combine those either. So this is completely simplified. However, I do have x terms on both sides, and you can't solve for a variable or isolate a variable when it's in 2 different places. So the first thing I'm going to have to do is let's collect all of our variables on one side. And it doesn't matter which way you start. I like to try to avoid negatives. So what I mean by that is I am actually going to move the 3x, which requires me to do a negative 3x, both sides. And when I do that, my result is 5x plus 7 equals, well, that zeroes out, and I still have plus 12, or just a plain old 12. Now I can move my number, so my 7, so now I can isolate that x term. That's going to leave me with a 5x on the left and a 5 on the right, and then I just have to divide both sides by 5, and that's going to leave me with x equals 1. So that one, we just had variables on both sides, so I just had to systematically move through the problem. Sometimes you can combine like terms, like this next one, number 17. On the left side, I see 2 and a negative 11, so I can combine those. I have a 2 and a negative 11. Those combined is negative 9. I still have my 5z, and on the other side I have some z's I can collect. So you always want to try to simplify first, if at all possible. 5z minus z is 4z, and then I still have plus 4. So now that I've simplified both the left side and the right side, now I can do the same thing I did in the above problem. I need to get all of my z's onto one side. So I'm going to subtract 4z from both sides, and that's going to leave me, let's ignore this right here, negative 9. 5z minus 4z is just 1z, so plus z equals, our 4z minus 4z cancel, or zeros out, and then we have a 4. And finally, let's isolate that variable term. My minus 9 and plus 9 zero out, so on the left side I'm left with z, and on the right side I'm left with 13. So this problem required some simplifying before I started moving terms, and then I had to collect my variables on one side before I could move through the problem. Now let's look at this problem. There's a lot of fractions in it, which makes it look a little bit intimidating, but what we're going to do is something called clearing fractions. So let's look at our denominators, which appear to be a 4, a 2, a 2, a 4, and if we think of that 5x over 1. So a 1, a 2, and a 4. So we need to think, what is the least common multiple, or what's the least common denominator between a 4, a 2, and a 1? And whatever that number is, we're going to multiply all the terms by that number. So 2, 4, and 1 all go into the number 4. So we're going to multiply everything. And what that's going to do is it's eventually going to clear out our fractions for us to where we don't even have to work with them anymore. Of course, it's okay to work with the fractions. You're using a calculator that you can use fractions, but if you were doing it strictly by hand, you would want to clear fractions first. So I have to multiply 4 times 3/4 and 4 times 1/2, and then I'm going to have to multiply 4 into everything on the right side as well. And because we're multiplying everything by the same number on both sides, it's not going to change the value of anything. It's just going to change the way it looks. So when I multiply 4 times 3/4, I'm going to get 3x. And when I multiply 4 times 1/2, I'm going to get 2x. Fractions are all gone. Multiply by 4 on the other side. 5x times 4 is going to be 20x. And 4 times half is going to be 2. And 1/4 x times 4 is going to be just plain old x. And again, you can get these if you're not comfortable working with fractions. Just take 4 times 3/4 and 4 times 1/2. And 4 times 5, and 4 times 1/2, and 4 times 1/4, and you'll get exactly what I got here. Now I can combine some like terms. So I can combine 3x and 5x into 5, or 3x and 2x into 5x. And over here, I have a 20x and a plus x, so that's a 21x plus 2. So I've simplified both sides as much as I can. Now I can start moving things around. So I want to get all my x's on one side. So I'm going to go ahead, and I prefer for my variable to be on the left. Even though it's going to create a negative for me, that's okay. That's going to give me negative 16x equals, that zeroes out, and I have a 2. And divide everything by negative 16. And that's going to leave me with x equals negative 1/8. And that would be my final answer for this problem. Now let's look at a couple cases where we are actually doing some other simplifying. We've got some parentheses involved, but the parentheses just indicates distributive property. So let's look at the first one. So if I distribute the 4, then that's going to give me 8t minus 20 equals 28. Now I can start solving because my parentheses are gone. As long as the parentheses are in there, you're not going to be able to solve. So you're going to have to simplify and get rid of those. So 8t, 28 plus 20 is 48. And one last step. And so t equals 6. So now let's look at the next problem. 26. This one doesn't look too bad. I can, there's no parentheses. I don't have to worry about distributive. I can't simplify anything on each side. I can't combine any like terms, so I can just jump into solving. So I want to get all of my x's on one side. Actually, let me draw my line. So subtract x, that's going to leave me negative 13. My x is 0, my x is 0 on the other side too. Well, that's new. And I get this. So all of my x's are gone, and I'm left with negative 13 equals 15, which is a false statement. That means that there is no solution to this equation. Which makes sense, because if you look at the original problem, if I have a number x and I take 13 away from it, there's no way that I can start with the same number and add 15 and have the two sides be equal. That's not even possible. So when this happens and your variables drop out like this and you're left with a false equation, then that is a no solution. If we would have done this and both the right side and left side had matched, so let's say our x's dropped out and both sides were 15 equals 15, it would have been infinite solutions. Most of the time we get a solution, but sometimes this happens, so just be aware.